Okay, we're going to look more closely into probability, and we're going to talk about adding probabilities. It's a little more than just adding two things together, but it's not that hard. So first we have to look at two symbols, the union symbol and the intersection symbol. So union means exactly what it sounds like. It means to unite. So if I were to unite two sets, I would just put them together. For example, let's say set A is, we'll use set notation, the numbers 3, 4, cow, moon, and the letter A. And set B is 1, 2, 3, 4, 5, and moon. Sets can be anything. Put some commas in there. If I were to unite set A, and there's our unite sign, with set B, it means we're joining forces. And if I were to unite them, it would be every element, that's what each individual thing is called, an element, put together. So basically I look at it and I take one set, and this is how I do it. I write it out. So I'm going to use the B set. I'm going to use 1, 2, 3, 4, 5, and moon. Now I'm not done. I just used every element in here. But now I need to put in every element of A. 3. Well, I already have 3 here, so I don't have to write it again. 4. I already have 4, so I don't have to write it again. Cow. Wait, I don't have a cow in here, so I'm going to put cow. I have moon. Wait, I need the letter A. And I'll just squeeze in my element sign, my bracket sign there. There you go. That's what A union B is. How about if I wanted to do A intersect B? Well, intersect is the same thing as saying I want the same in both. So in that case, I look here and I'll start 1. Is there a 1 in here? No. 2. No. 3. Yes, they both have a 3. So that's what gets written down the intersection. They both have a 4. They don't have a 5. Not a cow. Oh, a moon. They both have a moon. And that's it. That's the intersection. All right. A small high school surveyed 52 of its seniors about their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, we pick a student at random and we can place them into one of 4 events. All right, so let's see what's going on here. They've told us what M, F, C, and N stand for based on this chart. So if I look over in this chart, give it a quick understanding, I've got males and females, those that are going to college, those that are not going to college. And then we have, if you remember this from Algebra 1, there it is. There's the 52 that matches the 52 over there. So let's review on how to read this chart. N means number. Number of what? Males. Okay, based on this two-way table, that's what they're called. How many males do I have? Let me see. Male. Oh, I have 30. Okay, that's not that bad. How many females do I have? 22. Makes sense. 22 and 30 gets me 52. Not so bad. Number of C. C is going to college. Now, they didn't tell me who, male or female, just how many are going to college. 29. Oops. N of N. How many are not going to college? 23. Now we get the and. That's the intersection. How many are male and are going to college? So if I look at this, male would be right here. Going to college would be right there. And where do the two highlighted lines intersect? They intersect at the number 16. So there are 16 males who are going to college. All right. Who are female and going to college? All right, so once again, let's go to female. Who's going to college? 13 is where they intersect. And be careful, here now we have an or statement. Female or going to college. So female, it didn't say and. So I have 22 females. Going to college means male or female. So I have 29 who are going to college, and this is the whole adding probability. I'm going to take 29 females and 29 people who are going to college. I am going to add those together to get 51, but we can't count people twice. What does that mean? All right, I'm going to come back here and I'm going to draw those lines in again. This are all my females, whether they're going to college or not going to college. These are all my people going to college. So you see that 13 right there? We counted it twice. So what we have to do is now subtract the fact that we counted that twice. So 51 minus 10 is 41, minus 3 more is 38. All right, so if that doesn't make sense, think of it this way. They wanted me to count how many females there are. Okay, females. 13 are going to college. 9 are not going to college. That gets me that 22. Or, it means I'm going to add on people who are going to college. Okay, who's going to college? 16 males are going to college. 13 females are going to college. Wait, I counted those 13 twice. That's why I subtract one of those 13. And if you notice now, 13 plus 9 plus 16 gets me 38. All right, so now we're getting into the probability. So careful, this is asking probability. This was not asking probability. This was asking the number. That's why our answer was not listed as a fraction. Because remember, probability is all your possible outcomes on the bottom. Whoops, I spelled outcomes wrong, sorry. And all your successes of what you're looking for on top. All right, so what are we looking for the probability? What is the probability that a person picked at random? Okay, so there's my bottom number. How many people are there? Well, I'm looking at 52 seniors. Now, out of those 52 seniors, what desired successful trait am I looking for? I'm looking for females going to college. Okay, let me come back up here and clean this up so I can look at that better. Females going to college. So I'm going to look at this chart right here. Females going to college is right there, 13. You're female and you're going to college. All right, so that's 13 out of 52, which I could reduce to 1/4. Good. What is the probability? All right, so I know I have a fraction that a person picked at random, 52, would be female or someone going to college. Ooh, that's that or statement, so I can't count twice. Would be female. Okay, how many females do I have up there? I have 22 females. How many people are going to college? Going to college is 29. Wait, this looks oddly familiar. But I can't count this female 13 twice. Did I count it with the females or do I count it with the going to college? I can only count it once, so I'm going to minus 13. Oh wait, this is why it looks familiar. So that's 38 out of 52. And I can reduce that, 19 out of 26. Now, if I clean this up right here, it said represent this using either a union or an intersection. And that's basically how I got this number 13. Female going to college was an intersection, just like we did up above. This was female, and this was going to college, and their intersection was 13. The last question here says what we already talked about. Why, when I'm doing a union, can't I just add the probability of one plus the probability of the other? So the probability of female going to college, and just add, the probability of being a female, adding the probability of going to college, because we can't count those twice.